Uno, due. Okay, looks like we are ready to start. Okay, so for start, I'd like to apologize deeply to all of you because there was a serious mistake. My talk is not called Javaslang, functional Java done right, but Vavr, functional Java done right. So deep apologies go to Oracle because we have nothing to do with Javaslang. I don't know if you all know the story, but recently Javaslang was forced to change the name, well, to Vavr, because of some legal issues. Basically, having the Java word in the name of your framework was, let's say, controversial. And since we had quite a nice stickers, Daniel Dietrich, the owner of the project, opened his laptop, closed it, and saw that actually when you look at Java upside down, it spells quite like a waiver. Well, if you replace A's with lambdas. So this is how the name originated from, and yes, basically we are talking about something that used to be known as Javaslang. Well, so actually the nice thing was that we had such nice stickers, and now you could like basically just cut the waiver out of this and it would work. Well, I came up with my own proposition and created Lang from free stickers, but for some reason no one treated me seriously. Okay, so I'm Grzegorz Piwowarek. I work in Poland in a software house called Toke. Besides this, I'm a retired yo-yo player. Yes, that was a thing, and well, a retired musician as well. Yes, that used to be a thing. So if you want to find me anywhere, you can find me using this Twitter handle, or GitHub handle, um, Instagram handle, LinkedIn handle, and some other sites that I would probably not mention would not like to mention publicly. Okay, so let's go to the talk. Java 8 release happened, well, 3 years ago. Well, pretty much almost exactly 3 years ago. And it was a very special release. Well, first thing is that we've been waiting quite a long time for a new release. The second thing is that it promised us some new tools to play with, known from other world of functional programming, like lambdas, optional streams. So the excitement about Java 8 was quite a huge one. Okay, so everyone was very excited. But after playing with Java 8 for a while, people started noticing that this functional Java, obviously it has lambda expressions. Well, nice syntax for lambda expressions because you still were able to pass behaviors in the past using anonymous inner classes. We got also tools like optional stream, completable future, and actually not much more. So at some point, people started noticing some lags and complaining. Some people were also complaining that even some very basic operations, well, could have been done much easier. Okay, because we got rid of some of the boilerplate, but well, there is still quite a lot of boilerplate to deal with, even with such simple operations as mapping through all elements in a collection. So basically, people started complaining about that in Java we got only 3 functional control structures, namely optional, streams, and completable future. And if you have other, I have no idea what this is. In other functional languages, you had much more tools like this. Okay, there are in Scala you have try, either. In Haskell you have I/O monads and other stuff. Well, why not bring it to Java? Well, I don't know. I'm not here to answer this question. The other thing is a very nice feature to have is memoization, which is basically a form of a caching on some functions. There is no thing known as function lifting. There was no such highly anticipated pattern matching. no tuples. Even after many years, we still, if you want to have pairs or tuples, we either need to implement them by ourselves or use one of hundreds Git projects on GitHub. The other thing was that optionals for some reason were not serializable nor iterable. The official explanation for this is, well, it's very good, but not very convincing, because the official explanation goes like, states that it's not serializable because it was not intended to be. Okay. So the other thing is, well, the biggest problem for me personally was that there was new tools introduced, new APIs, but since Java needs to be backwards compatible, we ended up with situations where we had some APIs using like some legacy conventions and some new using new ones. So for example, in one classes we would have methods that would return optionals, and some other would return just naked objects that could be nullable. And this is a problem, okay, because there's lack of consistency in APIs and it creates problems. Another very cumbersome thing was to deal with checked exceptions in lambda functions. I'm not sure if you realize, but if you have a look at functional interfaces provided by JDK, you will see that those methods inside, they don't have any throws clause. It creates a problem, because now if you want to create a lambda expression with a body, well, and call some method in a body that will produce a checked exception, it's a problem, because now you need to manually just try and catch it, and usually just swipe it under the roof, under the carpet. Well, usually it's basically either just repackaging an exception to a runtime one or just ignoring it. Well, it can be really painful, especially if you have like a very long stream with a very long chain. And let's imagine that basically in few of them, you have methods that can throw an exception. And from your point of view, you might be interested only in the fact that the whole stream raised an exception. Okay, you are not you don't care about every single like the part of the stream. Okay, it's important if there is any exception. Well, it's a hell, because you need to put try catch in every step. So yeah, this could be really painful. The other thing is something that people called type pollution. If you have a look at functional interfaces in JDK, you will see that there are quite a lot of new keywords to remember appear there. You have function that represents a simple generic function. Well, you have predicates for functions that return booleans. You have consumers for functions that return voids. You have suppliers by consumers, unary operators, binary operators, by functions, and the list of names keeps growing. Okay. So at the beginning, when you familiar with the API, it's problematic, okay? Because suddenly instead of a function, you get something that's called binary operator, and you have no idea what this could be. So of course, it could have been like the names could have been organized in such a way that it was more intuitive. The other thing is that the thing that I mentioned before. Is that even some very simple operations were still quite boilerplate heavy and could have been done much easier. Well, obviously the list of all lags from the functional point of view is much longer, but let's stop on this point and go further. But before we jump straight into Javaslang, oh, sorry guys, Vavr, let's have a look for a second at this nice short method signature. Let's spare a minute or two. Well, let's pretend that those 2 minutes are over. So when we look at method signatures, well, we can notice always like 3 or 4 things. We have some list of arguments. We have types that get returned. There's the name of the function and name of the parameters. And when we see all of this information, we already have some intuition about what could happen in the method itself. Well, so now we are looking at this, you might think that, well, I might be returning the same list. I might be, for example, processing all those elements in that list, maybe uppercasing all of those strings. Maybe adding some other strings to those strings that are already there. Well, the problem is that Java language allows us to make things very unpredictable in at some points. So let's have a look at my implementation. So this is what I made. Um, as you can see here, a lot of weird stuff is happening over there because as you can see over there, I'm checking. I'm using internal state for making a condition. Um, I'm throwing an exception, which can be seen as another exit point of a function. I'm modifying current state. I'm adding some constants that come from the upper world. I'm modifying global state, modifying local state, pretty much mutating everything around and whatever is possible. And now imagine situations where we need to debug such stuff. Okay, it can be, well, it can be really problematic. But the biggest problem is that if you compose your solutions from unpredictable building blocks, well, it all adds up and you end up with a big pile of unpredictable code. So what we have here, we have a list of, actually when we look at methods, so we need to look at them not only at stuff that we see, okay? Because here we can see only we have a list of params, we have list of return values, names, and we can't base our assumptions what happens inside only after this information. Because the reality is that we should consider inputs or arguments, all possible situations that could like influence the outcome of the function. So in this case, all potential inputs that we have here is, of course, declared params, but we have also instance state and global state. They all can influence the results that we get. And when it comes to outputs, there are even more possibilities because except for value that the declared value that gets returned, you can mutate an instance state that will influence that will be an potential input of another method. Okay, you will mutate also global state that can be that can influence something else and end up with a big butterfly effect, basically. Well, also you have, of course, you can mutate params and throw exceptions, which are obviously at some point of return value where, well, in many cases not declared explicitly. So now let's imagine a situation if we have only declared params as all potential inputs and only declared return value as the potential outputs. This is a situation where basically when we know the inputs, when we know all of those blocks, it can be totally predictable. Okay, we can compose our solutions from small blocks, very predictable blocks, and when we compose them, yeah, there is a much bigger chance that it will eventually work without any additional problems. So there is some common misconception that the presence of lambda expressions in language somehow make it functional. It could have been seen when there were discussions on message boards regarding JDK8, and many people were stating that this language is now functional. Obviously, it could not have been further from the truth. Actually, if you try to Google, if you try to find like a very nice definition for the functional programming, it's actually very hard to do. I mean, I never managed to like find like the complete definition, but I found a really good one for this particular talk. So functional programming is about writing pure functions, about removing hidden inputs and outputs as far as you can, so that as much of our code as possible just describes a relationship between inputs and outputs. If we write code like this, we end up with stuff that usually is predictable and works on the first try. Object-oriented programming is about composing objects. Functional programming is about composing functions and small building blocks that work. And now, if we deal with small functions, small predictable elements, we minimize potential spots where you can make mistake. Okay, since we are dealing with strong static type languages, let's leverage this, okay, and let's end up with a code that has a bigger chance of telling us that something is wrong without actually running it yet. So in order to achieve such stuff, there are two concepts that should be recalled. One is immutability, and the other is referential transparency. Immutability is pretty intuitive. It's when you create objects and you can't modify them afterwards. Of course, it creates some limitations. It might be much harder to program using objects that don't mutate at all. But there is also much results from this are that you get much less errors. The other thing is referential transparency, which is all about situations where we have functions or methods, and if you call some method with the same set of parameters, and you should always get the same results, okay? And it doesn't matter if what's the global state, what's the instance state, what's the moon phase, okay? It should always be the same result. When we have such functions, we can call them referential transparent, which means they are, well, basically 100% predictable. So I don't see Mario here, but many people have some misconception about functional programming, because people say that, well, the real world is mutable and has a lot of side effects, so functional programming can't remove all of this. And yes, this is true. Functional programming can't remove side effects and, well, mutability from a real world. But by leveraging strong static typing and abstractions, we can pretty much encapsulate all of this stuff and deal with it in such a way that we don't deal with problems that mutability and side effects cause. So functional programming, as you know, we could pass behaviors in Java 7.6 using anonymous functions, but it still wasn't functional. Java 8, now we have nice syntax for it, it's still not functional. Well, if you really wanted to, you had, for example, Google Guava. There you had some immutable collections there, some nice APIs for some stream-like APIs, but still it was super painful to program like this. Well, if you want, you can program functionally without lambdas and other stuff, but it's really hard to program functionally if you don't have right tools for the job. In this case, let's have a look at Java Collections API. It's one of the basic building blocks of Java, and if you go through all of the methods, you will see that methods like add, remove, clear, et al. If you look at the return values, you will see that they usually either return nothing, or they return a boolean or something else, basically some metadata associated to the result, okay? But there is no, so this all suggests that the whole collections API is mutable, okay? Because if you add something to a list, you don't get a new list with a new element, but if you get void, it means the collections on which you call that method gets changed, okay? So even if you want, it can be super hard to, if you want to program using immutable structures, it will be super painful, okay? In Guava, you had something like immutable list, immutable map, and I don't know if you remember, well, there were still methods like add, remove, but what would happen there? They would just, instead of just doing anything, they would just throw exceptions, operation not supported, or something like this. Okay, so it was super uncomfortable for use. And it would create situations like, well, this is a very, very famous case, when you, for example, have a hash set, which is a mutable hash set, a hash set where you put a mutable object inside. Well, obviously, when you put something in a hash set, the hash gets calculated basing on the current state of the object. So if you modify it after this, you end up with silly situations like, well, you lose identities of those objects. Well, good luck with debugging this. So this is basically where the Vavr comes into play. This is Vavr. It makes it quite complicated, but basically this is just a new collections API for Java, plus set of tuples and new functional interfaces. There are also some experimental features like pattern matching, but we'll get to that. So when it comes to Javaslang, Vavr, there are three building blocks of it. There's this lambda, which will serve as a new basic functional interface. We'll have tuples and the new mighty interface of value, representing a container that can hold a value or not. So when it comes to new functional interfaces, they are super predictable. In Java 8, if you want to have functions, functional interfaces with more than 2 parameters, unfortunately, you need to define your own. Well, the other thing is, if they even created, if they provided functional interfaces that have more than 2 parameters, it would be hard to remember the names, okay? Because you have function, bifunction, trifunction, quad function, quintuple functions. Well, my English vocabulary can't handle this. Well, so when it comes to Vavr, it's super predictable, okay? Because you simply have one type of a function. You don't have by predicates, by consumers, binary operator, consumer suppliers, and other stuff, crazy stuff like this. Everything is just a function, okay? You have functions which have a number at the end of the class name, which denotes the arity of the function. So if you are looking for a function that has like seven inputs, you don't go for, well, 7 top. You just go for function and 7. So this is super intuitive. The other super nice thing is that all of them come with like with additional set of functional interfaces, but checked interfaces, which have first clause in the method representing the body of a lambda. So whenever we want to deal with it, we have a possibility of using just checked function instead of function instead. And even if you want to convert a checked function to function, well, like you can do it in a very, very easy way using some inbuilt static functions. Besides this, they all support function composition, which was actually already present in JDK version of functional interfaces. Other than this, you have lifting, which is a super nice concept, which we'll get to in soon. There's a support of carrying on all of them, and memoization, my favorite one. So let's have a look at lifting. In the world of maths, well, functional programming comes from the world of mathematics. So we don't have something like exceptions, okay? If you have f of x equals, let's say, 2, there is no option that suddenly, due to some moon phase, something bad happens. So here, whenever we have, let's say we have such function, and we have here division, okay? So obviously, in this case, we'll have, well, there will be, if you provide b as a 0, we'll have an exception. But if you look at the types, you don't really see this information that is that this exception could, well, this could happen anywhere. Lifting, applying the lift operation changes the return type of the function. So we perform lifting, and now we have a function that returns option, wraps our return result in an option. So we never have exceptions now, but in case when exception gets thrown, we get an empty optional. Okay, so this can be pretty handy. Well, assuming that you don't really care about what was in the exception. The other quite interesting, not that useful thing is carrying, although actually I managed to use that once or twice, is the way in which we can represent the functions of higher arities than 1. If you have a function of a, let's say, arity that is bigger than 1, you can always represent it as a function that returns another function of a lower arity. So as you can see here, we have function 2, which represents summing. We can easily create a new instance converted by using carried instance method. And now, instead of function 2, we get function of variety of 1 that returns another function. Well, it might look pretty abstract, but the idea is pretty simple. We are converting a function in such a way that now we don't need to provide all parameters, but we can provide them one by one. It can be super useful for deriving new functions based on what you have already. So if you have your function in such a form, you can easily apply partial application. So for example, now we can use apply only one parameter, and basically we changed a function that representing a summing of two elements to a function that always sums one element to two, okay? This is very, very basic example, not very useful, but if you compose like bigger solutions, it's actually quite useful. We had, I was building at my job document scanning engine. Basically the whole like the processing part was one big Java stream. Well, Javaslang we were using, Vavr we were using. And it became super handy that at some point we could just make carried functions and just perform partial application instead of just rewriting everything to get simplified forms of those methods. And now memoization, my favorite part. So we are in the world of functional programming. We operate on functions that are referential transparent, and they always return same values and they don't make any surprises. So basically, if we know that function returns always the same result for the same set of inputs, why not just cache results? Well, of course we can do this. So if we have like a function that let's say takes quite a long time to where the value takes quite a lot of time to compute, why not actually just cache them after calling the method for the first time? And yeah, obviously it works, and it's quite easy to achieve because there's only one instance method memoized that converts the function to the one that caches the result. So you can see it now with your own eyes. Well, the example is very bad, but shows how it works very nicely. Well, so let's create a function of math random. Well, it's the total opposite of what referential transparent means, okay? Because we accept actually math random to return another value each time it's called. Well, so let's break it. So we can memorize math random, and now if we call it after call it to first time, the value gets cached, and after we call the apply second time, the value gets returned from the cache, and we always get the same value. Okay, so that would be all for the functional interfaces part. Let's have a look at tuples now. So sometimes in the code we have situations where we could create, for example, a new class for returning like few values together, but there are situations where, they don't really deserve a new class to be created. In such case, we can deal with tuples, which are basically like a form of anonymous objects, typed anonymous objects. For example, if you have a look at Scala and other languages like this, for example, when you zip two collections together, you end up with like a new collection of pairs of elements. Okay, so for example, in such case, you don't need to create a new class, but you can use a tuple, an anonymous object that holds two together. So obviously, it's immutable. As you can see, the name of the tuple here is tuple2. So again, it's super predictable because if you want to have a tuple of 8 elements, well, you go for tuple 8. And obviously all of them can be created with the off-static method. And obviously the API is quite rich because you can, now after you created the tuple, now you can manipulate it easily using methods like map or transform. The other thing is you get even stuff like toSequence, well, if you want to iterate after all of them, well, if you really want to. So the most interesting thing is the value interface, which represents the container that can hold some value or not. Those types are those are options, which you probably already know from Java 8. Well, it's similar to optional. You have try, which is in this case something similar to optional, but instead of nullability, you deal with exceptions that can be raised in any point. Another thing is we have lazy, which brings lazy initialization of values to Java. Well, and again with some really nice map filter API. You have either, you have a new future, you have special validation monad, and what's super interesting that all of those containers, they extend iterable at some point. So this is some like the common denominator between the Java world and Vavr world. But okay, but optional try, why would you extend an iterable? Well, because actually, if you think from another side, from a different perspective, you will notice that optional can have 0 elements or 1. Okay, so it is a kind of a form of a collection or iterable that can called max 1 element. Same with try, lazy, and other things like this. Actually, it can be super useful in some situations that we will see in a second. What's also super nice is that the whole new Javaslang collections API also extends at iterable. So if we want Java and Vavr interoperability, we can achieve it by they are connected with iterable. Actually, recently there is some experimental feature, and there will be more experiments about returning collection views that are there is a concept. The guys are experimenting with this. They will be returning that you will be able to achieve interoperability not only by just using iterables, but also by using views that implement standard JDK interfaces, but delegate all the methods to underlying Vavr objects. So option, as you probably expect, it works similar to the optional, but so API is pretty similar. You have map, flat map, and if you want to get default value, you have get or else. There are few additions, but pretty much everything is pretty much the same. Additionally, of course, it's serializable, so it makes some things much easier. And here, let's have a look how we can leverage the fact that optional is iterable. Well, so imagine situations where you have a list of optionals and you want to filter out only values that exist in those optionals. Well, so now you have few options, but the most popular was, well, creating a stream. Then you would need to manually filter all optionals that have something inside. Then call optional get, well, which basically will be probably deprecated to another future Java releases. And then finally collect everything to list. Well, it sounds like pretty, well, quite a lengthy operation to do something pretty simple. But let's now imagine what happens when we know that option becomes iterable. If it becomes iterable, we can perform a flat map operation. Flat map operation means that we are flattening the nested structure. So if we have iterable holding iterables, we can flatten them to only one level. So if optional is an iterable too, we can pretty much collapse it. And it means that when you are flattening the nested collection, it ends up in a situation where optional becomes if something is in the optional, it becomes that value, and if optional is empty, it just collapses to nothing. As you can see here, you can simply achieve this using flat map, using Vavr only in one line. The funny thing here is that a few talks ago, some guys on the audience noticed that if you have an identity function O to O, it looks kind of like an O, so it's quite easy to remember. Flat map O, yeah, I can't unsee it now. Okay, so another thing, another tool is try. Try, as you know, is a tool like optional for dealing with exceptions. So the API and everything is pretty similar. Okay, you have map, flat map, that were filters, which looks just like in optionals and just like in the whole canon functional programming. You have the same looking API. How it works is when you have situation that when you are doing some action that can throw an exception, you can wrap it into a try and leverage a very nice API for dealing with exceptions. So here we are creating basically a new instance of URI, and as we know, URIs can throw many different types of exceptions. And now we can perform some declarative operations on it. In this case, we want to extract the scheme, and if it was successful, we can get it, or return an unknown in case some exception was thrown on the way. Of course, if you dig deeper, you will find much more like exception-specific methods for dealing with it. Another interesting thing is lazy, which, as you probably already expect, has the same APIs as try, optionals, and others. But in this case, we can deal declaratively with lazily initialized values. So if we have a very long computation, and we don't want to calculate it eagerly, we can create lazy of that particular complication, and then use the same API as in other examples for expressing our will. What would we do with this value if it got calculated? So here we have lazy of VLC, which states for very long computation. Then we are calling object to string using map, and string to uppercase, also using a map. So after creating the lazy instance, this is only expression of our will. It didn't get calculated yet. Everything will get calculated only when we actually reach for the value using get method. So the other super interesting thing about Java Vavr are functional data structures. When we are discussing immutability, well, it has some benefits, but it's not always, there are always some trade-offs. For example, if you want to deal with immutable data structures, well, you always need to create a copy if you want to modify it. So now imagine a situation where, let's say you want to add like a few thousands of elements or a few hundreds, thousands of elements to a list. Well, obviously you probably need to create a copy after addition of every element. Well, and this can be super inefficient. But wise people came up with the idea of persistent collections, which is basically an internal idea for building immutable data structures that, that don't waste that much memory. So if you really want to discover the whole subject, there is this talk from Devox, from the JRebel guy. I forgot his name. No, sorry. Definitely, it's called functional data structures. It has like a 1 hour talking about this, how it's implemented. But you need to remember that the core idea is to make this data structure recursive. So instead of just copying, and creating copies of everything, we are trying to reuse parts that were already existing. In this case, we can save quite a lot of memory on this. And now, if you have a look at the sequence type hierarchy from Javaslang, you will see that you have a lot of types that sound pretty similar to what you already know. You have arrays, vectors, stacks, lists, queues, streams. But there is one thing I'd like to point to you, which is a stream, which might be pretty confusing, because in Java 8, streams are not collections. This is basically a very fancy form of iterator for dealing with stuff, but this is not something that holds elements. But here, stream is a full collection. So yeah, we are not limited to stuff like using it only once. So this is super nice. In Java it was a limitation, but here it was implemented from scratch. And now the best parts of all those types in Javaslang is that when you use the code completion tool from your favorite IDE, you will be mind blown with the amount of tools that you have over there. Well, you probably can't see all of them, but it's important if you see that quite a lot of them. I remember when I was dealing with Java 8, um, at the beginning for me it was, well, when I was looking at the Stream API, it was overwhelming. But after some time, I was noticing lags. For example, there's no possibility of doing distinct using a custom comparator, okay, a custom equals method. And this would be super useful. Or for example, you can't zip two streams together. This was super limiting in some cases, and you need to just help yourself with some external libraries for this. But here, basically everything you might need is already there. So if you want to, of course, you can do basic distinct, but you can distinct by using custom comparator, custom function. You can add elements to a stream, which was super cumbersome in Java 8. You can even return combinations or cross products of all elements that are in the stream. Okay, you can cycle stream. Okay, converting a finite stream to infinite one, and so on and so on. You have quite so. Even if you find something, if you were looking for something useful for you and you didn't find it, you can always go to GitHub, raise an issue, and it will be implemented. Our guys will explain you very politely why why it won't be. This is also the other very interesting thing when you compare two different communities. For example, remember when I was starting functional programming with Scala, there was this mailing list, and I remember that whenever people were asking some questions, well, they might have got an answer that was something like, just go to elementary school, learn basic math, and then come back. Well, but these guys from Vavr are super community friendly, so I remember that recently my friend submitted a very big pull request to Vavr, which got closed, but instead of just very like authoritative no, instead of Daniel created a very big like blog post about it to explain some technical design decisions that were made and why this won't be implemented. So it's super polite and super friendly. So even using these new tools, you can do crazy stuff like this one if you want to, impress girls or make your friends in a team hate you. The other thing that guys are experimenting with is pattern matching, which is basically a very extended form of switch case known from Java. Well, obviously we don't have, there's no native language support for this, so it's super limited, but still it can be helpful in some situations. So when you're thinking about pattern matching, in relation to switch case, it works pretty similarly, okay? Because you have some value that you are switching and some cases that it can fall into. So for example, here you can see that we are matching the I, and it can be in, there are three cases. It can be even, can be odd, and can be, something else, just in case, if it could ever be. So as you can see here, we are using predicates for specifying, if that value fits or not in this particular case, and we have a special $ brackets for representing wildcards. In this case, it doesn't make much sense because after two cases we know that this is exhaustive, but it's super necessary in other cases. Well, if you don't create an exhaustive cases, you can always use option instead of off, and in such case, if it doesn't get matched, you end up with an optional. Well, if it didn't get matched, empty optional. Obviously, this is it gets much more interesting because you don't need to you are not limited to using predicates, but you can put actual values inside. So you can match using predicates and particular values. It gets even deeper because if you are not limited you're not limited to using like fixed values. You can create patterns. So for example, here you can match cases using like knowing only part of the object. If you look at the second case, you will see that you have a local date. You have here all local dates with 2016, and it doesn't matter which month or day it is. well, you just and get access to it later when you calculate the value. So it can be super useful, but it can be super cumbersome if you want to use it um, with your own classes, because obviously it might look super weird, but this needs to be generated. Okay, so there's a separate project that allows you to generate your own patterns, um, which can be on some not very comfortable. Okay, so you can also perform pattern matching using actual types. So predicates, cases with actual values, and actual types. So it's the equivalent of instance of. And obviously the pattern matching comes with the set of predefined predicates, basically from every basic scenarios. So it makes it super easy to compose your cases from them. If you would like to look at the real-life scenario, you have a situation like here where you have cases with different parameters, and on the right side you can see that there are some methods that should be run when one of the parameters was present. Obviously, you are not limited to using pattern matching standalone. You can combine all those tools together. You can compose tries with optionals, for example, and with pattern matching when recovering. And when you connect all those tools together, it creates super fluent, nice API that can be read very easily, and there's much lower likeliness of ending up with some unexpected stuff in there. So basically, this was the review, the short demo of the Vavr library, Vavr core. But Vavr is much more than this. There are additional modules that can be used. The one very interesting one is Vavr JWT. I don't want to know what's inside. Additionally, you have special module for pattern matching if you want to experiment with this. There is a property testing framework, Vavr test. Additionally, you have Vavr Jackson for of course, serialization, decentralization support with Jackson, and Vavr Render, new experimental tools that guys are playing with. So basically, that would be all. I hope you like the new tool that will inspire you to write more functionally in Java. Thank you very much, and we don't have much time, so just catch me after and ask some questions. Thank you very much.